Welcome, mathematicians. In this video, we're going to explore a real world situation about shopping at a flea market. Now, if you haven't been to a flea market, it's like an open air market often where people have set up tables and booths and are selling all different types of things. It's often a place where you can get good deals and find really interesting, unusual things. Now, we're going to explore this problem, this situation together. So, I'm going to be asking you a variety of questions or giving you tasks to do. So, along the way, you're going to have to pause the video and answer the question or complete the tasks. And then we're going to return to the video and work on them together. So, here's our situation. T-shirts at a flea market cost $4.50 and shorts cost $6 each. You have $108 to spend on shirts and shorts. So that's a lot of money. So you're probably going to be able to buy a lot of t-shirts and shorts, kind of different combinations. Maybe you're buying them for friends, maybe you're buying them for gifts. All right, your first task is going to be to write an equation that models the possible combinations of t-shirts and shorts that you can buy for $108. Before we start, let's just standardize our variables. So we're doing the same thing. I've just defined T. Let T be the number of t-shirts that are bought, and S is the number of shorts that are bought. So please pause me and try to write the equation yourself. For my equation, I know that I need the money that I spend on t-shirts combined with the money that I'm spending on shorts to equal the total money that I have to spend. All right, my total money is $108. For t-shirts, I know that I need to convert the number of t-shirts that I buy into money. And I can do that by multiplying by 4.5 because it's $4.50 for each t-shirt I buy. And I'm going to combine that with the money I spent on shorts. If I buy S shorts and each pair of shorts is $6, then it's going to be 6S. So there's an equation that models this constraint that we have about how many t-shirts we can buy and how many shorts we can buy, and it has to equal $108. Now, this equation models a relationship between these two quantities, number of t-shirts bought and number of shorts bought. My question for you is, which of these two quantities in the input and which is the output? So pause me and decide for yourself. Well, what did you decide? Guess what? Either of these quantities can be the input. There's no clear independent, dependent relationship between these two quantities. When we have a linear relationship between two quantities that has no preference for input or output, we typically write the equation in standard form. I'm just going to write that here, standard form. And this equation is an example of an equation in standard form because both of the variables are on one side of the equation. We're going to talk more about standard form in a later video, but I just wanted to let you know that that's a really common way that we can write linear relationships. All right, now that we have this pattern, let's think a little bit more about the possible combinations of t-shirts and shorts you can buy for $108. I'm just going to create a table that we can start collecting some of this information. Now, because it doesn't matter which variable is our input, which is our output, I'm just going to randomly put the number of t-shirts here as my first column. And we're going to still think of that as T. And then we're going to do the number of shorts as the second column. And we're going to just keep that variable again as S. All right, now what if you only want to buy t-shirts? How many possible t-shirts can you buy? Pause and try to answer this question. If I'm only going to buy t-shirts, that means not going to buy any shorts, 0 shorts. So I can come back to my equation and I can substitute 0 for S. So this is going to turn into 0, and I'm left with 4.5t is equal to 108. I'm going to divide both sides by 4.5. This is a great time to use a mechanical calculator. And when I do that, I find out that t is 24. So that means if I don't buy any shorts, I can buy 24 t-shirts with that $108. All right, let's think about it in the other way. What if you only buy shorts? How many can you buy? Please pause me and try to answer this question yourself. All right. For this one now, if I'm only going to buy shorts, that means there are going to be 0 t-shirts. And I can do the same idea. I know my T is 0, no shorts, plus 6 times the number of shirts is going to equal 108. That's going to turn into 0. And we have 6S is equal to 108. Divide both sides by 6. And S is going to equal 18. Again, you can do some mental math, or a great time to use a mechanical calculator. So I know I can buy 18 pairs of shorts if I don't buy any t-shirts at all. It's now time to do a little visualizing. Let's create a graph to start visualizing this relationship. Since I had my t-shirts as in my first column, I'm going to put that also on the x-axis. So I'm going to label the x-axis as T, which is number of t-shirts. And I'm going to label my y-axis. This is going to be S, which is my number of shorts. I have 2 points that I can plot because I know when I have 24 t-shirts, I have 0 shorts. And when I have 0 t-shirts, I have 18 shorts. So let's plot those points. 24 t-shirts is 0 shorts, and 0 t-shirts will let me get 18. Because 2 points define a line, I can draw a line through this. If you're doing this by hand, please take a ruler because you want this to be as accurate as possible to get that, to connect these points using a straight line. So I'm going to draw like that. There we go. These points where the line intersects the x-axis and the y-axis, these are called the x-intercepts and the y-intercept. So for the x-intercept, this is what is the value for x when y is 0? And this was 24. So x is 24 when y is 0. And for the y-intercept, what is the value for y when x is 0? And so this was x 18. And we'll be talking more about intercepts as we go through this unit. Your next task. We have a graph now. I tried to draw that line as accurately as possible. You need to use the graph to find 2 more combinations of t-shirts and shorts that you can buy for $108. Please pause me and find 2 combinations. Realistic combinations are going to be any point on the graph where both the number of t-shirts and the number of shorts are whole numbers. Like there's no notion of really buying half a t-shirt or a third of a pair of shorts. So what I did is I went through and I looked for points on the graph that were on the grid lines. I've also recorded them in the table. So for example, this point right here, use a pen, this point right here would be 4 pairs of shorts and 4 t-shirts and 15 pairs of shorts. This point right here tells me I have 16 t-shirts and 6 pairs of shorts. So all combinations where the cost would equal $108. Next, because this is a linear pattern, there must be a constant rate of change. Pause and calculate that constant rate of change. Because we picked, and again, this was a choice that we put t-shirts on the x-axis and shorts on our y-axis, we know that the constant rate of change is going to be the change in shorts over the change in t-shirts. So that's how we'll be looking at our constant rate of change, our slope of the line. Now, how did you calculate slope? Did you use 2 value pairs from the table? Did you create a slope triangle on the graph? I'm going to use, to calculate slope strategy, I'm going to use these x and y intercepts to find my slope because it's going to make my arithmetic so easy. My change in shorts, I go from 0 minus 18. My change in t-shirts, 24 minus 0. And I'm left with negative 18 over 24. They share a common factor of 6. I'm going to make the whole slope negative, and I'm left with negative 3/4. Maybe you use the table to do something similar. In fact, if we use the table, I know if I go from 18 to 15, that's -3. 0 to 4 is +4. And again, I see that -3/4, that constant rate of change. I can also find the constant rate of change at the graph. Let's say I go from this point. I'm going to start there. I'm going to come down and then to the right. So I went down, which is negative, and I went down 9 units. And then I go to the right, which is positive, and I went to the right 12 units. So if I think about my change in my change in shorts over change in t-shirts, -9 over +12, and that also gives me -3/4. So no matter how you calculate that rate of change, that slope, it's always going to be the same. It's always going to be constant. Next task. What does this constant rate of change mean in the context of the problem? And I'm going to add a few units here. It's -3 shorts, or -3 shorts over 4 t-shirts. Pause and jot down your ideas about what does this mean for the problem. Here are my ideas, and let's compare them to what you were thinking. I'm starting it with a slope of -3/4. I can interpret this as -3 shorts over +4 t-shirts. And if I think of it this way, I'm thinking if you buy 3 fewer pairs of shorts, you can buy 4 more t-shirts. Another way I could think about it is +3 shorts over -4 t-shirts. And then for this case, if you buy 3 more shorts, then you're going to have to buy 4 fewer t-shirts. So this negative slope is really showing us this give and take of the number of shorts you buy to the number of t-shirts you buy so that you maintain this constant amount of money that you're allowed to spend, $108. In this flea market situation, we learned that not all linear patterns have a clear input and output quantity. Instead, for example, like in this problem, both of the quantities can play the role of the independent input quantity. In this case, sometimes when you go to calculate your slope or get a table of values or make your graph, you just have to choose one to be your X, your input, and the other one to be your Y, your output. But either can play those roles. For these types of situations, we often write our equation in standard form. And this idea again of standard form is both of your variable terms are on one side of the equation. And then typically there's going to be this constant number on the other side that's representing some form of constraint. We're going to be talking more about standard form and the y and x-intercept in a later video. But before that, I want you to explore another situation. This one's going to be about Mr. Grouchy. I'll talk to you soon, mathematicians.